welcome everyone. I hope everyone can see my screen, which tends to be the the first sentence on on Zoom calls nowadays. If not, please let me know. So as already introduced, my name is Marco, and we'll be talking a little bit more about Terraform 0.13 and kind of rise of the modules that it brings with the latest stable release. So we'll mostly be talking about modules today, which are basically the basic building blocks of Terraform. And as the quote from our friend from Hashicorp once said, it's basically an abstraction of a common blocks of configuration into the reusable infrastructure elements. So that means that whenever you write your Terraform code, you are basically using modules. So it follows the basic keep your code dry rule. So it kind of prevents of repeating yourself. Of course, you can still make mistakes, still repeat your code, but kind of the basic concept is there and it's available for you to use. So as I said, when you write in Terraform, everything is a module, even if you're not using a module. So even if you're not calling external modules, you're basically using a so-called root module that has the same principles as if you would include any kind of external modules there. And since 0.13 is quite a big version bump, specifically around how modules work, that's why I kind of tend to refer to it as a rise of the modules. It's probably not as violent as in this movie, but let's have a look what's there, what are the big kind of changes that we were all kind of hoping for since probably since the beginning, I guess. Before we kind of go deep into the new features, let me kind of introduce myself. As I said before, I work as a senior IT consultant at Scale Factory. We are a DevOps consultancy based in London, which probably doesn't really matter nowadays since we're all kind of locked in our homes. We are AWS Advanced Consulting Partner and Kubernetes Service Provider. I have a really extensive kind of ops background there, and I'm a really passionate contributor and supporter of open source. If I'm not doing any kind of IT related things, you would probably kind of find me nowadays socially distancing somewhere hiking around in the nature. So let's just quickly look what we're gonna talk about today. So initially, I will start with kind of going briefly to Terraform, kind of throughout the history from the beginning. I'm going to mention a couple of big kind of milestones in the Terraform timeline, how it all kind of developed through time, what kind of features we got through different releases. Then I'm going to talk a little bit more about probably the most kind of wanted features out there. Those are specifically ones that I mentioned before. Those are module improvements. So we're going to briefly talk about how modules were expanded, what kind of functionality we got, and how we can better reuse those kind of basic building blocks when we are composing our code. Then we're going to touch a little bit more about provider ecosystem that got quite a refresh there as well, where the whole ecosystem was got a little bit of a revamp in a sense of how we are including providers and how those can be used in a more efficient way. There are also a little bit of enhancements and breaking changes that I will kind of briefly touch before we kind of dive into the demo. So if the demo gods are with us, I'm gonna try to demo all those new features. And if there is some time left at the end, I was thinking we could kind of have a quick overview of a new Terraform 0.14 that's already in the alpha release, and we can give it a spin and see what the upcoming features are, or what's already in the code base. At the end, I'm gonna just wrap it up with conclusions and how the path forward looks like. As mentioned, there is 0.14 definitely in the cards, but probably the path towards 1.0 is not that far now. So let's just quickly have a look of the Terraform timeline throughout the history. So we can kind of split it up in maybe 3-4 big milestones. This is just my probably personal opinion there. And I just pick through the change log and kind of pick the milestones that kind of brought most of the features throughout the history of Terraform. So we can start with pre kind of 0.10 era where we still had provisioners. We didn't have really workspaces. We have so-called state environments, which was a little bit different concept. And we already had remote state and kind of basic locking there. As we got to the release of 10 or 11-ish, the state environment was kind of refactored into workspaces as we know them now. So you're probably familiar with the workspaces in Terraform where you can have state kind of isolation from the configuration. So you can have same configuration applied to different parts of the state that you're applying to your cloud layout. So for example, you can have the same configuration for a dev or validation environment, but you still want to keep state separate because obviously there are different kind of variables used or values that you're using when you're applying your infrastructure as a code. So what else happened there? We got module providers. The apply phase was streamlined, and Terraform registry was introduced. So we got private and public Terraform registries. And this is kind of what we got with the 0.10, 0.11-ish. With 0.12, that was introduced just in 2019, which is a little bit more over a year ago. There were some big changes coming. So the whole Hashicorp configuration language version 2 was introduced with some big kind of language changes where we got first-class expressions, generalized types. We got iterations, which is probably the kind of the biggest thing of 0.12 with dynamic blocks. So you can easily dynamically build repetitive blocks such as stacks, for example, and you can have some basic iterations through collections as map and lists and kind of construct new map and lists using for loops there. The plans became a little bit more structural. We got a bit better structure with plans, which is more appropriate for machine consumption. And there were some improvements with error messages that were produced. And the latest stable release, as I mentioned, is 0.13 now, or as I call it, Rise of the Modules. So obviously that kind of gives the hint away where the biggest change there is definitely how modules are handled, and definitely the provider ecosystem got a big revamp there. So let's have a quick look what module kind of expansions we got there. So first of all, there is a better module usability and functionality now. That means that the configuration logic and kind of automations is very much simplified in a way that probably the most kind of wanted or weighted feature that was introduced was count. So if you were using Terraform before, this is probably the kind of the feature that was missing. So you can now actually produce multiple instances of a single module by using either a count or for each. Those are kind of different concepts. So with count, you would get a tuple or a list of instances of modules. With for each, you will get a map. And in a demo later on, we will kind of go through the examples, what that actually means for code and how you can use each of those concepts. there is a kind of a small footnote there, so you cannot really mix those interchangeably in the same block of code. And you have to be aware that by using those new kind of concepts, you can actually introduce some indirect module level dependencies that might not exist there before and might kind of produce a different kind of dependency graph when planning and applying your infrastructure. And yeah, of course, there is another kind of important bit that I wanted to mention. So you cannot use a provider block per module instance. This kind of breaks the backwards compatibility there. So if you used to use the provider block in your modules, this is definitely not a recommended way how you would use providers, even in O12, but with O13, and specifically with the new module expansion syntax, this is definitely not supported anymore, and will produce an error if used with multiple instances. So for example, if you use your infrastructure in AWS, for example, typically what people usually did was they configured regions using module configurations in their modules, and this is not a supported configuration anymore. And there are different workarounds around that, which I will be talking a little bit more in the next couple of slides. So the second kind of the biggest change there was module dependencies that were introduced as well. So as we know, we have two types of dependencies, so implicit or explicit. And previously, what the difference actually is, previously module instances were not nodes in the dependency tree. So there was just a separate namespaces, and we could kind of work around that by doing an implicit kind of dependency there, where you would use a value from one module to another module, which would kind of create this implicit dependency throughout the graph. But now with O13, you can actually do an explicit dependencies, which is probably a far more coarse declaration of dependency that originally it's encouraged using HCL. So as usual, as you are used from the resources before, this is probably the last resort in case of Terraform cannot automatically resolve your dependencies through other means. And as usual, you can create dependencies now with the depends on meta argument that kind of ensures your order of resource creation or model creation in this case. As I mentioned at the beginning, there is also a big provider ecosystem revamp there. So the third-party providers are now automatically installed. Before, you would have to manually ensure they are in the path. There are big improvements to Terraform registry as well. So Hashicorp kind of joined the Terraform registry as a single point for providers and modules now. And obviously there was a big kind of a revamp with the user interface, where the search is a little more streamlined now and should give you better results and easier searching. And of course, the provider block, we have now a provider block namespace separations. So there is a new required provider block introduced now, where you would include your providers via their namespace using the source argument. And at the same time, you can still specify different constraints as version and other bits that we used to do with the old syntax there. By default, the Hashicorp provider namespace is actually just Hashicorp/provider. The full syntax is actually name of the repo. So in this case here on the slide here, you would see that it's, in this case, it can be registry.terraform.io, which can be omitted if it's using the default one, which is registry, and then just the provider kind of namespace and type of the provider. As I said before, you can only use a single provider per module instance, but you can still use modules providers meta argument to kind of pass on the providers to the modules. and use proxy provider configurations in the modules itself and configure those further as necessary. And as I said before, the nesting will be deprecated in further versions. So what actually provider ecosystem brings now, it's definitely simplifying the installation of community providers. So the official Hashicorp supported providers work out of the box as used before. The partner support providers needs a required providers directive now and a source where the provider is pulled from. And if you're using locally installed providers like third-party providers, you can put it in a predefined path, which is, it was changed a bit. It introduced the namespace there, a new namespace separation as well. So it will, now it lives in /plugins, repo path organization, which usually maps to the provider repo, and then provider name, version, and the platform which you're using it on. And it can be configured using the provider block, as you can see here with providers, and then you can set up the custom plugin and specify arguments for version, source, where you're going to put it off, and different kind of constraints you would pose on it. If you have a quick look at the source code here, so how the new syntax looks like and how the provider's namespace are configured. So we are using the required providers block, where I think one of the kind of powerful features there is you can actually, with the new namespace separation, you can actually have two providers that are ensuring the same functionality, but presented in a different namespace throughout the code. So in this example, it's a kind of a made out Hashicorp DNS provider that you can use, and a hypothetical alternative provider, which is called MyDNS. And obviously you can see we are using different sources for those providers, but later on we can configure them separately, and the resource would be, the resources would automatically be prefixed with a provider namespace. So even though the functionality is the same, you can use them throughout the code in a similar approach, but with a different prefix. So what are the other enhancements there with the O13, right? So the first most, I mean, no, not the first, actually, the first out of the most important kind of improvements, which are probably not the flagship ones, but quite important as well. And I think it's super useful. So you probably find yourself usually where you want to do kind of a variable checking, and this couldn't be done throughout the native Terraform code in the past, but with O13, there was a custom variable validation rules introduced. So kind of to be exact, those were already an experimental feature since 012, I think 26-ish. You would still need to enable it using the experiments equals and just enable it using variable underscore validation feature. So that actually enabled the feature, and you can have 0 or more validation rules to check the, the values of your variables as you're passing in. And I will demo that later on in the demo. So the other enhancements there are, which are the important enhancements worth mentioning, are definitely the ones that affect how you are interacting with Terraform Cloud. So there is a streamlined authentication process where you can just simply run Terraform login now, which would kind of streamline the whole login process, where you are redirected to the Terraform Cloud, and it automatically creates a token for you and updates the local configuration there. And of course, there were some changes. So when interacting with Terraform Cloud, you can use state pushing and specifying specific targets when applying changes. There is also a new command, Terraform providers mirror, which kind of goes nicely with the new namespace, where you can mirror your provider, for example, in an environment that is either highly regulated or doesn't have internet access, and create a providers mirror in your environment and access those providers without need of pulling those from the registry every time you run your infrastructure as a code. It's quite useful for the CI/CD pipelines as well. Of course, the Terraform CLI now supports TLS 1.3, and there are some breaking changes as well. So, for example, a non-default providers needs specifying a source now, otherwise it will fail to find those. And there was some improvements with locking, so it was improved, and the table store schema was changed a bit, so it actually requires a primary key now, which needs to be called as previously lock ID, but it has a strict type of string. And there is some deprecation on the Terraform CLI regarding the FreeBSD and macOS, which doesn't support some of the older versions there anymore. Just kind of to show, yeah, I'm actually missing an image here, which got lost from the slide. Sorry for that. So I just wanted to show what happens if you are doing a Terraform provider's mirror. It just basically replicates the stuff from a remote repository there. So before we dive into the demo there, let's see how you can get started. So easiest way to get started is getting your binary from either releases.hashicorp.com or just terraform.io/download. Before you start doing your upgrade from your previous versions, ensure that you have no pending configuration changes, where this kind of eliminates the possibility of having some outstanding changes that might affect how different versions apply different code. One, and definitely a good kind of recommendation there is keep your code either backed up or in a versioning system. So when you run the Terraform All13 upgrade command, you can actually follow up on the changes that were made in place in your code. And just to note there, it only supports a gradual one release jumps. So if you're using, for example, 0.11 now, you probably need to go through Terraform 0.12 upgrade first in order to get the 0.12 features in. And to achieve that, you actually have to run the older Terraform version. So 0.12 is still a subcommand in Terraform 0.13, but it would just produce an output saying that you need to run it with older Terraform to achieve that. And as usual, for other nodes, please follow the change log for more details. A couple of things that I wanted to mention here. So data resource reads can no longer be disabled. So this is also a kind of a constraint to new module expansion there, where it needs to read data resources, and that cannot be disabled during the planning phase anymore. The destroy time provisioners cannot refer to other resources anymore. This was deprecated, and the new directory structure for manually installed providers is in place, as I mentioned before, throughout the new kind of namespace. And of course, when you do the upgrade, if the required provider is not provided by the upstream registry, you would see this kind of a message, which is kind of self-explanatory there, and kind of really tries to kind of hint you where either to look for providers. It tries to give you a good hint where to look for them, or what kind of change you need to do in order to get them in place. So that's enough of slides. Let's switch to demo now. I'm sure everybody's excited as much as I am to see if that's going to work. So I'm just switching to my console here, just kind of to give you a quick overlook. It's a fairly simple code I have here. So I wanted to keep it simple to kind of focus on the changes rather than the code. So first, what I want to show you, the main TF file, which is just simple. We are using just a simple resource type random pet, where we are generating some random names. And what we are actually doing is we have some local variables defined here, where we are going to show you how you can use those in connection with new features to generate multiple instances of modules. So what we're going to do here is we're going to create a list of bucket names, where it's gonna consist of predefined names that we are defining with random path resource up there. And the second local variable is called resources, which is a map, actually, map of key values, where the key is represents the bucket name here, and the value is the actual. It's actually a bucket name of the instance of the module. It's called bucket 1, bucket 2, and the value represents the actual bucket name in the AWS environment there. And then we are actually using an upstream S3 bucket module here, and we are using it as an external module. So intentionally, I was trying to show you how to pass on the providers to the modules now. So you would use the providers meta argument here, where you just pass your providers down to the child module. So the child module would use the same AWS provider I'm using in my core module. And then we have two modules here. They're using the same upstream S3 bucket modules, and we are using different approaches for those modules. So in the first one, we are using the new for each loop, where we are looping through the local resources variables, and we are setting bucket name based on the value of that for each loop. And as I mentioned before, the key is actually the identifier of the module instance there. We're not doing anything special on the bucket. We're just blocking the private access to that repo. And later on, I'm just going to try to demo how this is going to change if we set explicit dependency on the second module there, which can be either a module or a different resource, doesn't really matter. And the second module is doing the same thing, but with a different approach. So we're using count. And in this instance, we are using the length function to decide how many elements we have in the bucket names list here. And we are creating buckets with the bucket names and using count index as index to get the value from that list. And we're gonna also notice what the difference is when we instigate modules using different approaches. So in the first one, we will get the map of modules. In the second, we will get a list of modules. So let's quickly plan this out. So for the sake of this test, I'm just using local state, not dependency, but I will create buckets in my AWS account for this. So if we inspect plan really quickly, what I said before, when we are creating buckets 1 module, you're going to notice that we are getting a list here, as I said. And when we are creating buckets 2, we are getting actually a map here, which is using a key as an identifier for instances. So let's just quickly apply that now. And what I want you to be kind of aware of here is the ordering, how the things are applied. So as I said before, I'm not using any kind of dependencies here. So you will notice that by default, Terraform is just kicking off module deployments in parallel. So as you can see here, started with both of buckets 2 modules and then immediately kicked off buckets 1 modules, right? Kind of makes sense, you know. It figured out there are no dependencies between those 2 modules. Let's just start them doing in parallel, and boom, we have modules created with random pet names, which is exactly what we expected. So if we have a quick look in the console now, we should end up with 4 S3 buckets actually that were created with random pet names. And this is exactly what we have here. So let's just quickly destroy that infrastructure now. Just quickly, shouldn't take long. And here we go, it's gone. Luckily, we don't have any complex infrastructure here, so this actually happens quite quickly there. So let me quickly introduce a dependency now. I'm not gonna do a plan phase because the apply phase, since I think O12 does the planning anyway. So these are kind of joint phases there. So we're gonna notice still the same kind of plan output. Yes, we agree. Let's kick that off. And as I said before, please note the difference here. So what the difference actually is here, as you're gonna note, we imposed a dependency here. So what happened? Terraform said, okay, there is a dependency. So we need to take care of the buckets 1 first, which actually happened here. And then after we have buckets 1 sorted, it kicked out the buckets 2. So you can actually see that depends on is actually working with modules now as well. Cool, right? So let's look at another new feature that I wanted to show you. So as I mentioned before, you can have a variable validation now as well. So you can use a kind of simple true and false conditions now. And how you can achieve that is when you set your variable, like in this example region, which defaults to EU West 1. And we can easily set the validation on that variable with the validation block. And it takes 2 arguments, condition and error message, where condition needs to be true or false, where we can easily use the can function here and use a regular expression here and just look if the value of var region actually matches or not matches, really starts with EU hyphen. So it would only allow EU regions here. And if this doesn't match, you can actually emit a custom error message, which is actually quite cool that you emit your own message. So it can actually make sense to the condition that you're checking it against. And in this case, which is going to emit only EU regions, it must start with EU hyphen. So let's just quickly change that variable here. So we're going to override that and we're going to set it to US West 1, for example, and let's do another plan. What's going to happen? Boom, immediately the validation happens before the planning phase. So we immediately end up with an error saying that there is an invalid rule for variable, and you would get your custom message emitted saying only EU regions, it must start with EU hyphen, which I find it quite a cool feature to have embedded in Terraform code, and kind of, you don't have to have your own check set up in your CI/CD pipelines or something like that. So just the last thing I wanted to show you before we wrap it up, because I think I'm actually at time already. Yeah, so another example here is I have another example of how we can upgrade or start upgrading here. As I mentioned before, nothing fancy. We have a single resource called random string with ID random. It just generates a random string, nothing too complex. And what we have here is when we apply this, this is just going to output a random string that we generated. So quite straightforward, right? So how would we actually upgrade that code? Because obviously you can see that that is definitely a syntax of 011, and we don't specify the providers block here as well. So what we can do is simply we can run Terraform 012 upgrade to kind of bump it to 012 first. And it kind of emits, okay, are you sure you want to do this? Because it's gonna replace your configuration in place. Of course, we are sure. And what it's doing, it's actually changing that bit. And you can notice it's changed the syntax to the 012, where you have first class expressions and variables, and you don't need the whole interpolation that we had to do before, which is quite nice. And it did create a new file called versions, and it put a constraint in. So you cannot really run this with Terraform older than 012, which you would say kind of makes sense, right? You upgraded the syntax, so it makes sense to put that constraint in. So let's just quickly do the 013 now. So I'm just gonna switch to 013. I'm using the latest version here with tfenv, which is quite convenient to switch Terraform versions. So what I'm gonna do, just run the 013. I just wanted to show you, as I mentioned before, you can still run the 012, but as I mentioned, you need to run it with the older Terraform binary there. So let's just do the old 13 now. So I made the same warning, upgrade complete. Obviously, we didn't have any kind of conflicting things in our code. And if we check the outputs, look the same. The code hasn't really changed much. The thing that changed is actually versions. So what we would expect here, right, is the constraint of old 13 and maybe even something more. So, and this is exactly what happened. So it imposed the new constraint on required version of 13, and it added the required providers and automatically went through our code and figured out we are using the Hashicorp random provider, and it has automatically added the required providers block with a source to that provider. So this is how you can easily kind of get started with the O13 upgrade. So just a quick,
I'm sorry.
So I think I'm over time, so I probably don't have time to run the 14 change, but I can do it at a different occasion there, or if people are interested, just get in touch and we can do it on a different occasion there. So kind of to wrap it up here, so as I said before, if you had to take something from this presentation, it's definitely things to remember. You know, what new features O13 is bringing is definitely there are module improvements. We have module expansion now with count and for each that we can use. And we have explicit dependencies that we can put in modules, and we can avoid the whole kind of workarounds that we used to do, right? So I reckon everybody did that in the past, where, you know, you would put use an output of one module to as an input to another one to kind of impose you know, implicit dependency there. And then there is a whole new wider provider ecosystem with auto loading of, you know, third-party providers with a hierarchical namespace where you can have same functionality in a different namespace and use it in with different configurations. We can mirror our providers now, and we can have isolated environments now. So the whole kind of expansion where it widened up the whole ecosystem and enabled different third parties to include even more actively there. And there's also a custom validation rules, which I personally think are quite cool feature to have, like I'm demoed before. So this is definitely something to take away from this. And the Terraform Cloud improvements and streamlined CL authentication process. I can quickly show that, but let me just wrap it up here with, there is also improved state locking, as I mentioned before. And obviously the O14 is already in alpha, which you can get and grab from releases.hashicorp.com, where we are on a good path to O1 with, you know, with possible features that were kind of hinted on the last Hashiconf there. With there's going to be improvements on CLI cloud parity. They probably going to work on sensitive values. Maybe easing up the import of resources, and probably in the module testing. So that kind of wraps up my presentation. Since I'm really over time, I don't want to take much time off for other presenters there. So I'm just going to wrap it up here and kind of leave you with resources for further reading. I will make this available to organizers afterwards and share it with the group. And I'm happy to take questions now, or you can either reach out to me via different kind of social media.